Hello, hello everyone. Today we are going to discuss this problem on code forces called stay or mirror from recent division 2 round. So you are given a permutation p1 to pn of length n, and you have to build an array of the same length n in which you can do a flip of that number at index I, or leave it as it is. So as the question says, stay or mirror. So at uh, ai is equal to pi, or mirror it, ai is equal to 2n minus pi. Now by doing optimal operations, we have to find the minimum possible number of inversions in the array that we will make. And yeah, that's the general definition of permutation and general definition of inversion in an array. So yep, problem statement is pretty self-explanatory, and so are the sample input and outputs. So one thing to notice here is that n can be maximum up to 5 into 10 to the power of 3, and sum over all test cases doesn't exceed 5 into 10 to the power of 3. And so what that suggests is that we can write O of n square solution, okay, as the time limit per test is 2 seconds. So let's take a look how we can try to solve this problem. So I'll take this test case as a reference to work with. So yeah, so while I was attending this contest, I was not able to come up with the solution for the same. So it has a clever trick involved within the solution. So I'm directly telling the trick to you, and yes, that goes like this basically. So uh, what what you can consider here is that, so consider the minimum element 1. So 2, 2, 3, 4, 1, 5 and 6. So here n is equal to 6. So either we can stay with 1 or mirror this one. So this 1 can be either 1 or 11. Okay, so one thing to notice here is that, so the trick basically was that, like, if you don't change this 1, all the elements, all the other elements 2, 3, 4 and 5, 6, if you don't change this 1, will always be greater if they stay or they mirror. Okay, so if 2 mirrors, it will be 2 into 6 minus 2, that is basically 10. Then 3 would be 9, 4 would be 8, 6 would be 6 itself, and 5 would be 7. So either if they mirror or stay the same, they will all be basically greater than 1 if 1 stays and doesn't mirror. So if 1 doesn't mirror, then the number of inversions that involve 1 as one of its indices would be 3, right? So this one and this one, so these 3 basically would be contributing to our inversions, which have 1 as its one of indices. And if 1 doesn't mirror, okay, and if 1 does mirror, okay, so if 1 does mirror, then no matter what, if you mirror all the other elements or let them stay as they are, they all will be smaller than 11. So this was the trick. So if they mirror or not, they'll be smaller than 11. So if I make 1 as 11, if they mirror or stay same, the number of inversions that would involve 1 would be 2 now. Is it making sense? basically 11 5 and then 11 and 6, those would be two inversion pairs that would be present in the array which consist one. Okay, so like if you don't mirror one, then it would be 3 no matter what, like the pairs involving one, right? So if you don't mirror, then it will of course be 3, because if you stay or you mirror, then they all will always be greater than 1. And if you mirror the 1 and make it as 11, then all the other elements would always be smaller than this 11 if you stay the same, basically if they stay the same or mirror themselves. So that is basically the thing. Now this kind of directs us to think greedily, right? So um, so let's hop on to the 2 and see what's happening. So greedily I will make this 1 as 11. Okay, so greedily I will make this 1 as 11 to get two inversion pairs which contain this 1 as one of its components. Okay, so now our array becomes 2 3 4 11 5 and 6. Now let us take a look at 6. Oh, okay, sorry, let us take a look at 2. What was I even talking about? But yeah, so if we mirror it, we'll get 10, and if we stay with 2, then we of course have 2. Then what you will notice here is that, so if we stay or mirror this, like its interaction with 11 doesn't change, right? It's always gonna be smaller. So we can kind of neglect this 11 after it is like fixed. Okay, so we can kind of neglect this 1 which was here, or like after making 11 we can basically ignore this, because we know that like there can't be more inversions like which will be from this index. Like we have already counted this when we were making 11 from 1, so we can basically ignore it, and so it will be equivalent to counting inversions, or like counting minimum inversions via mirroring or staying the same in this array, plus, so that's the function of the input, that as output would be function of this input plus 2. Like this was the minimum that I could get if I flip or not flip 1, basically. Okay, and as you can see here, uh, in number of inversions in this given array 2 3 4 5 6, not given, like manipulated array 2 3 4 5 6 is already 0. Like we don't need to perform any operations, and why would we want to, because it's already 0. And plus 2, in this case your answer would be 2. Okay, so let's check. Yeah, the answer is 2. So let's once again let's check on this test case. Okay, fine. So here also we'll take a look at 1 and count the inversions. If we don't mirror 1, so then they will be 2, and if we mirror it, then also they will be 2. So let's mirror it. So or if you kind of stay same or mirror it, doesn't really matter, as we have seen before. So our answer would be f of 2 comma 3 comma 5 comma 4 plus 2. So again, here what we can do is that, so our n is equal to 5 here. So let's check on this 2, how can we minimize. So this 2, if we don't flip it, its contribution to inversions is 0. So basically our answer would be 0 plus f of 3 5, 4 plus 2. Then let's take a look at this 3. So we will basically take a look at numbers in increasing order of fashion. Okay, so 0 plus, again the contribution from 3 would be 0, and f of 5 comma 4 plus 2. Now let's check for this 4. So if we stay the same, then number of inversions would be 1. Okay, and if we mirror it, then 4 would become 2 into 5, that is 10. 10 minus 4, 6. So it would become 5 and 6, and number of inversions would then be 0. So we would like to flip that 4, and it would basically become 0 plus 0 plus f of 5 plus 0 plus 2, and this is basically 0 as it's only one element, and answer for this test case will also be 2, and which is indeed the case as we can see here. So that is basically the trick involved in the solution. So I think I hope you get the gist of the solution. Let's head towards the code, the implementation part of it, to understand how we can implement it. So it's easy to implement. It's basically order of n square idea. So I'm taking the input and basically storing the value comma index pair and sorting it based on the first parameter as my priority. So it would be sorted first based on this v of I, basically the value in the array, and we will have them in the increasing order of fashion as we want to as per our solution. And for every element in our pos vector, basically position vector, f denotes what will be the number of inversions if you flip the current element, and nf denotes what will be the number of inversions if you don't flip the current element. So this for loop calculates it for not flipping the element, so basically not mirroring it, staying the same. So iterating over whole array, if that iterator is equal to our index, so basically we don't want to compare the element to itself, we'll just continue. Otherwise, if our iterator is less than index, so if that value in that vector is greater than our current value, then there's an inversion there. Okay, and we increment nf plus plus. Otherwise, if j is greater than index, so if j is greater than index, so if our value is greater than the value at that index, then the inversion will be counted. So that is basically this for loop doing. And in the same way, I have counted it for flipping the element as well. Note that the value will become 2 times n minus the value if you flip its value, and if value by flipping is less than by not flipping, we will flip the element and add f to our answer. So basically inversions after flipping. Otherwise we will not update we will not update the value at v of index, and so basically just add the inversions after not flipping the element to our answer, and finally output would be answer by 2. So why answer by 2? So we will basically be counting inversions twice, right? So we are iterating over the whole array. Okay, so for inversion pair I comma j, so suppose if it is 5 comma 3, such pair is there, and when I will be iterating on 3, I will count inversion with this 5, and when I am counting with this 5, I will count inversion with this 3. So it's basically only one inversion, but we are counting it twice. So finally we have to divide answer by 2 and output it. Okay, so I hope you found out this video useful. Yes, so I have made a video after a long time. So yeah, that was it. Hope it helped you, and stay tuned. Bye bye.